Hello everyone, I'm Oktavian Nikky Abprianto, and now I will present about image processing final exam. The first question is, please answer the question below. A. What is definition digital image? A digital image is a representation of a real image as a set of numbers that can be stored and handled by a digital computer. In order to translate the image into numbers, it is divided into small area called pixels or picture elements. B. What is basic three steps of image processing? Image processing basically include the following three steps. First, importing the image via image acquisition tools, analyzing and manipulating the image, output in which result can be altered image or report that is based on image analysis. C. What is Python? Python is an interpreted high-level general-purpose programming language created by Guido van Rossum and first released in 1991. Python designs philosophy emphasizes code readability with its notable use of significant white space. Its language construct an object-oriented approach aimed to help programmers write clear, logical code for small and large-scale projects. Python is dynamically typed and garbage collected. It supports multiple programming paradigms, including procedural, object-oriented, and functional programming. Python is often described as a batteries-included language due to its comprehensive standard library. Second, please answer the question below. A. Explain three libraries for image processing using Python. First is OpenCV. OpenCV is one of the most popular and widely used libraries for image processing and computer vision. This oral library can be used with many programming languages like C, C++, Python, Java, but the library of Python binding is the most popular one. Not only image manipulation, but complex deep learning algorithms related to computer vision can also be implemented using the library easily. The best thing about OpenCV is that it's cross-platform and it can work with mobile devices also. And the second one is Pillow. Pillow is an image processing library for Python derived from the PIL or the Python imaging library. Although it is not as powerful and fast as OpenCV, it can be used for simple image manipulation works like cropping, resizing, rotating, and grayscaling the image. Another benefit is that it can be used without NumPy and Matplotlib. And the third one is SimpleCV. SimpleCV is a Python framework that uses computer vision libraries like OpenCV. This library is quite simple and easy to use and can be really helpful for quick prototyping. This library can particularly be useful for those who don't have a knowledge of different image manipulation concepts like agent values, color spaces, and bit depth. B. Please mention three transformations of images. First is resizing. Resizing an image means changing the dimension of it, be it width alone, height alone, or both. Also, the aspect ratio of the original image could be preserved in the resized image. To resize an image, OpenCV provides cv2.resize function, preferable interpolation method are cv2.interarea for shrinking, and cv2.intercubic slope, and cv2.interlinear for the zooming. By default, interpolation method used is cv2.interlinear for all resizing purpose. The second one is translation. Translation basically means that we are shifting the image by adding or subtracting the x and y coordinates. In order to do this, we need to create a transformation matrix M. Here, the tx and ty value are x and y translation, and y translation value, that is. The image will be moved by x units to the right and by y units downwards. So once we create a matrix like this, we can use the functions cv2.warp_affine to apply it to our image. The third argument in cv2warp_affine refers to the size of output image. And the last one is rotation. To rotate an image using OpenCV Python, first calculate the affine matrix that does the affine transformation or linear mapping of pixels, then warp the input image with the affine matrix using cv2.getRotationMatrix 2D. We can specify the center point around which the image would be rotated as the first argument, then the angle of rotation in degrees, and a scaling factor for the image at the end. Rotation is also a form of transformation, and we can achieve it by using the following transformation matrix, which is R equals cos sin cos. 0 is this angle of rotation in the counterclockwise direction. So the C, please mention low-level image processing algorithms. Low-level image processing algorithm includes edge detection, segmentation, classification, and feature detection and matching. The third question, what is definition of A. OpenCV? OpenCV, or Open Source Computer Vision Library, is an open source computer vision and machine learning software library. OpenCV was built to provide a common infrastructure for computer vision application and to accelerate the use of machine perception in commercial products, being a BSD licensed product. OpenCV makes it easy for business to utilize and modify the code. B. Pixel. The pixel, or a word invented from picture element, is the basic unit of programmable color on a computer display or in a computer image. Think of it as a logical rather than a physical unit. The physical size of pixel depends on how you've set the resolution for the display screen. If you've set the display to its maximum resolution, the physical size of a pixel will equal the physical size of the dot pitch. Let's just call it the dot size of the display. If, however, you've set the resolution to something less than the maximum resolution, a pixel will be larger than the physical size of the screen dot. That is, a pixel which will use more than one dot. C. Convolution. Convolution is a simple mathematical operation which is fundamental to many common image processing operators. Convolution provides a way of multiplying together two arrays of numbers, generally of different size, but of the same dimensionality, to produce a third array of numbers of the same dimensionality. Convolution involving one-dimensional signal is referred to as 1D convolution or just convolution. Otherwise, if the convolution is performed between two signals spanning along two mutually perpendicular dimensions, example, if signals are two-dimensional in nature, then it will be referred to as 2D convolution. This concept can be extended to involve multi-dimensional signal, due to which we can have multi-dimensional convolution. And D. Multi-dimensional array. A multi-dimensional array is an array with more than one level or dimension. For example, a 2D array or two-dimensional array is an array of arrays, meaning it is a matrix of rows and columns. It's like of a table. A 3D array adds another dimension, turning it into an array of arrays of arrays. Multi-dimensional array concept can be explained as a technique of defining and storing the data on a format with more than two dimensions, or 2D. In Python, multi-dimensional array can be implemented by fitting in a list function inside another list function, which is basically a nesting operation for a list function. And E. Transformation. An image transform can be applied to an image to convert it from one domain to another. Viewing an image in domains such as frequency or Hopf space enables the identification of features that may not be as easily detected in the spatial domain. Image transformation typically involve the manipulation of multiple bands of data, whether from a single multispectral image or from two or more images of the same area acquired at the different times, example multi-temporal image data. Either way, image transformation generates new images from two or more sources which highlight particular features or properties of interest better than the original input image. F. Filtering. Filtering is a technique for modifying or enhancing an image. For example, you can filter an image to emphasize certain features or remove other features. Image processing operation implemented with filtering include smoothing, sharpening, and edge enhancements. G. Feature selection. Feature selection is the process of isolating the most consistent, non-redundant, and relevant features to use in model construction. Methodically reducing the size of datasets is important as the size and variety of datasets continue to grow. And edge matrix. The image matrix defines the number of rows and columns in our image that make up the pixel or voxels in our image. These rows and columns are determined by the number of phase and frequency encoding steps. This can be selected by the technology separately and will make up our image. The matrix representation of an image also allows for functions such as adding brightness or rotation. 4. Please answer the question below. A. What is 2D convolution? Convolution is involving one-dimensional signal is referred to as 1D convolution or just convolution. Otherwise, if the convolution is performed between two signals spanning along two mutually perpendicular dimensions, if signals are two-dimensional in nature, then it will be referred to as 2D convolution. This concept can be extended to involve multidimensional signals, due to which we can have multidimensional convolution in the digital domain. Convolution is performed by multiplying and accumulating the instantaneous values of the overlapping samples corresponding to two input signals, one of which is flipped. This definition of 1D convolution is applicable even for 2D convolution, except that in the latter case, one of the input is flipped twice. This kind of operation is extensively used in the field of the digital image processing, wherein the 2D matrix representing the image will be convolved with a comparatively smaller matrix called 2D kernel. The kernel is called the image filter, and the process of applying this kernel to the given image is called image filtering. The output obtained after applying the kernel to the image is called the filtered image. Depending on the values in the kernel, it performs different functions such as blurring, detecting edge, and so on. And B. What is bins? Bins range based on histogram terminology. Bins is the histogram above shows the number of pixels for every pixel value from 0 to 255. In fact, we use 256 value bins to show the histogram. It could be 8, 16, 32, etc. OpenCV uses his size to refer to bin. Dim is the number of parameters for which we collect the data. In this case, we collect data regarding only one thing, intensity value. So here it is 1. Range, it is the range of intensity value you want to measure. Normally, it is 0, 256. For example, all intensity values. See what is process of dilation. Dilation is just opposite of erosion. Here a pixel element, example, a pixel element is 1. If at least one pixel under the kernel is 1, so it increases this white region in the image or size of foreground object increases. Normally, in cases like noise removal, erosion is followed by dilation, because erosion removes white noises, but it also shrinks or object, so we delete it. Since noise is gone, they won't come back, but our object area increases. It is also useful in joining broken part of an object. D. What is different between RGB and HSV? According to the people on Quora, the difference between RGB and HSV, or why they use HSV than RGB, is because people use HSV color space for color detection or thresholding over RGB or BGR, is that HSV is more robust towards external lighting changes. This means that in case of minor changes in external lighting, such as pale shadow and etc., hue values vary relatively lesser than RGB values. For example, two sets of red color might have similar hue values but widely different RGB values. In real-life scenarios such as object tracking based on color, we need to make sure that our program runs well irrespective of environmental changes as much as possible, so we prefer HSV color thresholding over RGB. Fifth, please explain the method mentioned below with its brief definition, strength, and weakness for processing data. A Kenny edge detection. The Kenny edge detector is an edge detection operator that uses a multi-stage algorithm to detect a wide range of edges in image. It was developed by John F. Kenny in 1986. Kenny also produced a computational theory of edge detection explaining why the technique works. The Kenny edge detection algorithm is composed of 5 steps. First is noise reduction, second gradient calculation, third is non-maximum suppression, fourth is double threshold, and the last one is edge tracking by hysteresis. The advantage of Kenny is that it produces very thin and clean edge. The next step, non-maximal suppression, or NMS, will achieve this. NMS is done by tracking along the height value in the output image, then checking for maximal gradient in a 3x3 neighborhood. The center pixel has to be the highest in the direction perpendicular to the edge, or else it will be set to 0. And the primary disadvantage of using Kenny edge detector is that it consumes a lot of time due to its complex computation. B. Harris corner detection. Harris corner detector is a corner detection operator that is commonly used in computer vision algorithm to extract corner and infer features of an image. It was first introduced by Chris Harris and Mike Stevens in 1988. Upon the improvement of Moravec corner detector. Compare the previous one, Harris corner detector takes the differential of the corner score into account with reference to direction directly. Instead of using shifting patch for every 55-degree angle, and has been proved to be more accurate in distinguishing between edges and corners, since then, it has been improved and adopted in many algorithms to pre-process images for subsequent application. Some advantages of Harris corner detection are that it has powerful stability in noisy images and more accurate in distinguishing between edges and corners. While the disadvantage of Harris corner is it needs to set a different threshold for each image. C. HAAR cascade. HAAR cascade is an object detection algorithm used to identify faces in an image or a real-time video. The algorithm uses edge or line detection features proposed by Viola and Jones in their research paper, Rapid Object Detection Using a Boosted Cascade of Simple Features, published in 2001. The algorithm is given a lot of positive images consisting of faces and a lot of negative images not consisting of any face to train on them. Some HAAR cascade benefits are that they are very fast at computing HAR-like features due to the use of integral image, also called sum area tables, They are, they are also very efficient for feature selection through the use of the AdaBoost algorithms. The downside to hard cascade is that they tend to be prone to false positive detection, require parameter tuning when being applied for inference or detection, and just in general are not as accurate as the more modern algorithm we have today. That's all from me. Thank you for your listening. I'm Oktavian Nikky. See you in the next video.